Let's show what the derivative of y equals sine x will be. Okay? So what I'm going to do will be to use the first principle of differentiation by starting with y increasing with change in y and infinitesimal change in y. This must have come clearly from x plus an infinitesimal change in x. Now, making change in y the subject of formula gives me sine x plus change in x minus what y is, which is sine x. At this point, let us recall the following from trigonometric ratios of compound angle formula. Let's recall the following. That sine A plus B, we were told, is sine A cos A plus cos A sine B. And sine A minus B is equal to sine A cos A minus cos A sine B. Now, subtracting, if you call this equation 2 and you call this equation 1, subtracting equation 2 from 1 implies having sine A plus B minus sine A minus B, giving you the result 2 cos A sine B. However, if you call A plus B x and let's call this equation 3 and call A minus B y to establish a relationship, then you would end up having that A plus B, which is x, and A minus B, which is y, can be added or subtracted one from another. Adding these two to get A, to establish a relationship for A in terms of x and y, will give you 2A equals x plus y, implying that A is simply x plus y over 2. And doing same for B would imply subtracting equation 4 from equation 3. And that would imply that 2b, because b minus minus b will give you plus b, which is 2b, and this would be x minus y, implying that b is x minus y all over 2. Now, based on what we have just done, you will now see that change in y can now be written as 2 cos this plus this over 2. That is x plus change in x plus x over 2 sine x plus change in x minus x over 2. This simplifies to give you 2 cos x plus x is 2x, so you end up having 2x over 2 plus change in x over 2 times x minus x goes, so you end up having sine change in x over 2. From this point, we can simplify to have this 2 cancels 2, so we have x plus change in x over 2 divided by sine change in x over 2. So at this point, we have obtained a relationship for change in y. But take note, we want to establish the derivative of this function. So the next step we are going to do, having concluded this step, will be to divide change in y by change in x. This is the step where you aim to obtain the gradient function, change in y over change in x. And that would mean dividing this by change in x. So I'm going to do this, x plus change in x over 2 sine change in x over 2, all divided by change in x. Now, algebraically, this next step is the same as what you have here. So if you have all this divided by change in x, I could use this 2 to divide change in x in this denominator, and the expression will remain valid. Okay? So it is just like dividing the numerator and denominator by 2, and that will give you cos x plus change in x over 2 times sine change in x over 2, all divided by change in x over 2. Now, finally, let us rewrite this result as this. Cos x plus change in x over 2 I'm going to put one side and take this expression sine change in x over 2 all over change in x over 2 into one bracket. Okay? Then comes the next stage, the third step I'm going to be taking. In the third step, you are going to be obtaining the limiting value as change in x tends to 0 of your gradient function. And by definition, the limiting value as change in x tends to 0 of your gradient function defines the derivative of the function with respect to the independent variable, in this case x. That will mean taking the limit of this whole expression. And if you are familiar with the concept of limit, the limit of a product of two functions or more is the product of the limits. So this would mean taking the limit. If I'm taking the limit of the left hand side, that is the gradient function, it means taking the limit of this entire function, which is a composition of two functions. So that would mean taking the limit as change in x tends to 0 of cos x plus change in x over 2 times taking the limit as change in x tends to 0 of this new function change in x over 2 all over change in x over 2. If you have watched my previous video, you will realize that this result had already been established to be 1, because as change in x tends to 0, you would have change in x here becoming 0. 0 over 2 would give you 0, and 0 plus x will give you x. So it means for the first instance, dy dx will give you cos x for this particular part of that product. For this other part, this result, the limiting value as change in x tends to 0, is the same as the result we had established for sine theta over theta as theta tends to 0, and we established it to be 1. So this will be times 1, implying that dy dx equals cos x if y equals sine x, and this completes the proof of that problem.